We're going to take one more video to discuss theoretical and experimental probability. And there's lots of different formats for this, so that's kind of why we're stretching it out. Suppose Susie's friend Stephanie has a satchel of stones, but the shades of the stones are secret. So inside a bag, Stephanie has some rocks that are all different colors. Here's what we know. There are a total of 70 stones. There are 3 colors, black, white, and gray. And when Stephanie selected 10 stones, these were the results. So she actually conducted an experiment. We're going to use some experimental data in order to solve a problem. So I have 6 black stones, 1 white stone, and 3 gray stones. Let's predict the number of stones of each color in the satchel based on the experimental probabilities. So we're going to find the experimental probabilities first. Remember, experimental probabilities come from a data table or an experiment. So the probability of getting a black is 6 out of, and then we need to figure out what our total is. So 6 plus 1 is 7, plus 3 is 10. So there's a total of 10 stones, and that's what it says up here when Stephanie selected 10 stones. Total of 10. So this is going to be 6 out of 10 or 3 out of 5. Probability of white is going to be 1 out of 10, and the probability of gray is going to be 3 out of 10. We're going to use some proportions to determine theoretical probabilities. So we can set up a proportion, and we want to know there are actually a total of, excuse me, there are 70 stones total. So we did an experiment where we picked out 10, and now we want to try to figure out how many out of the 70 are each color. So how many out of 70 is equal to probability of black, 3 out of 5. So you guys have gotten really awesome at proportions, and they come back one more time. So cross multiply. 70 times 3 is 210 is equal to x times 5, or 5x. Divide both sides by 5. So I have 210 divided by 5, and I get 42. So I'm thinking that there are about 42 black stones inside this bag. White stones, very similar. I don't know how many out of 70, but I know I pulled out 1 out of 10. So again, cross multiply. 70 times 1 is 70. 10 times x is 10x. Divide both sides by 10, and I get 7 is equal to x. So we think there's about 7 white stones in the bag. And then last but not least, gray. So I want to know how many out of 70 are gray, and that's going to be equal to 3 out of the 10 that I pulled from my experiment. Cross multiply. 70 times 3 is 210 is equal to 10 times x, or 10x. Divide both sides by 10, and I have 21 is equal to x. So I'm thinking that there are going to be about 21 gray stones in her satchel. All right, suppose the actual number of stones in the satchel are 10 white, 20 gray, and 40 black. How accurate is your prediction? What causes the prediction to be different than the actual values? So if I look at my prediction, I thought there were 42 black, and there were actually 40. I thought there were 7 white, and there were actually 10. And I thought there were 21 gray, and there were actually 20. So the values are pretty close. So my prediction was pretty close. Not perfect, but it's pretty close. What causes the prediction to be different? Well, experiments are designed to give us a good idea of the truth, but they're rarely perfect because they are an experiment. This could be due to things like human error, missing information, something that scientists call bias, So sometimes the bias of the experimenter leads the data to not be exactly the way it should be. Things like that. Maybe the black stones were lighter, and so they all came to the top, and that's why she picked out more of the black stones in the experiment. Maybe the white stones were heavier and they all sunk to the bottom. We don't know. That might be some missing information. Or maybe that caused bias. Stephanie was more likely to pick the stones on the top of the bag. So, again, we don't know all of the truth, but we did get a pretty good idea of what the contents were inside that bag.